In this session, we will try to discuss few more examples about the entropy. We have already discussed entropy in our last session with full detail, but here in this session, we will try to discuss few more examples so that we can better understand the entropy. In our last example, we assume that the symbols are not equiprobable, like we have already assumed that the symbols with a different probability. But in this example, we are considering that we have four symbols and each symbol have a equiprobable probability. And then we need to calculate the entropy in that case if the symbols are equiprobable. We already prove that if the symbols are equiprobable, then you can write the entropy is equal to log 2 of and m is the number of symbols. Mn is the number of symbols. You can use both formulas of the entropy like this. This is the basic formula of the entropy. H is equals to sum of 1 I is equals to 1 2 4 pi multiplied by the information. Or you can use this formula, entropy is equals to log 2 of m, and m is the number of sample. We know that number of sample is equals to 4, so you can take log 2 of 4, so 2 raised to the power 4, and we know using logarithmic rule the power is always come in front of log 2 base 2. So this is equals to 1, so 2 multiplied by 1, the answer is 2. But if we use the other formula, basic formula of the entropy, like if you are multiplying the probability with the information, like here in this case, we can like even we can write directly that we have four symbols. So you can write 4 multiplied by the probability. So probability is 0.25. So 4 multiplied by 0.25, still answer is equal to 1. So like here even you can write individual like 0.25 log 2, the probability is 0.25, similarly 0.25 log 2 divided by 0.25, so four times you are repeating. So this is so you see 0.25 multiplied by 2, 0.25 multiplied by 2, 0.25 multiplied by 2 plus 0.25 multiplied by 2, so 4 times 0.5, so still you get the same answer, 2 bit per symbol. So let's have another example. For a discrete memoryless source, there are three symbols with the probability P1 is equals to alpha and P2 is equals to P3. Like the you have three symbols and the probability of first symbol is alpha and the probability of second symbol is equals to the probability of the third symbol. And you need to calculate the entropy. So given data is probability of first symbol is alpha and probability of second symbol is equal to the probability of first symbol. So the total probability we already know that P1 plus P2 plus P3 is equals to 1. And then you can write the probability of P1 is equals to alpha, and we know that the probability of P2 is equals to P3, so that is why you can replace P3 with the P2. So you can simplify this formula. So you alpha plus 2p2 is equals to 1. So you can calculate p2 is equals to 1 minus alpha divided by 2. So this is the probability of a symbol 2, and this is also the probability of a symbol 3, because we said the probability of p2 is equal to p3. And we know the basic formula of the entropy, so that is equal to k 1 2 3 pk log 2 1 by pk. The first symbol probability is alpha, so log 2 1 by alpha plus second and third probability of second and third symbol is equal, so that is why we are multiplying with the 2. So the probability is 1 minus alpha divided by 2, so log 2 1 by 1 minus alpha divided by 2. So this is third denominator, it will move upstairs. Okay, so this 2 will be cancelled with this 2, so remaining is alpha log 2 1 by alpha plus 1 minus alpha log 2 2 by 1 minus alpha. So let's do one more example. So this one, so that we can better understand the entropy. So show that the entropy of this source with the following probability distribution is 2 minus 2 plus n divided by 2 raised to the power n. So the probability of symbol 1 is 1 by 2, the probability of symbol 2 is 1 by 4, probability of symbol 3 is 1 by 8, and so on. The probability of symbol n is 1 by 2n. And we need to prove this distribution. So this is basically the a series, power series, and we know the formula. If we open the power series formula, the answer is one by 2 plus 2 by 2 is equal to 2 plus 3 by 2 raised to power 3 plus dash 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 plus n by 2 raised to power n. So if you insert or if you calculate the entropy of this distribution, the answer should look like that. So you know the formula of the entropy is equals to pk log to 1 by pk. So keep inserting the formula because k is 1 to n. So p1, you can write p1 log to 1 by p1 plus p2 log to 1 by p2 plus p3 log to 1 by p3 plus so on, and then plus pn log to 1 by pn. So what is the probability of P1? We know that is 1 by 2 log 2 1 by 2 plus 1 by 4 log 2 1 by 4 plus the third is 1 by 8 log 2 1 by 8 plus 1 by 2 and log 2 1 by 2n. You know these are the third denominator 1 by 2 1 by 4 and 1 by 2n. So that is why they will go upstairs. So that is log 2 of 2, so 1 by 4 log 2 of 4 plus 1 by 2 n log 2 of n. So we know, so the answer of log 2 of 2 is 1, so that is why 1 by 2 multiplied by 1. The answer of log 2 of 4, so the answer of that one is 2, so 1 by 4 multiplied by 2, and then you know because this is 1, because 2 raised to power 2, so 2 is in front of the log and log 2 of 2 is 1, so that is why 2 multiplied by 1. Similarly, this is the power of 2 n, so that is why n is always in front of that, and log 2 of 2 will be equals to 1, so that is why n divided by 2 n multiplied by 1. And you know, so the entropy was that is equals to 1 by 2 plus 2 by 2 to power 2 plus 3 by 2 to power 3 and then plus n by 2 to power n. So that is proved that we have to prove for this type of distribution. Let's do one more example. The source emit three messages with the probabilities of message 1 is zero point 0.7, probability of message 2 is zero point 0.2, and the probability of message 3 is zero point 0.1. So it means that the messages are unequally likely because the probability is not, they are not equiprobable. Probability of each is different. So what you have to do, you have to calculate source entropy, max entropy, source efficiency, and redundancy. Source entropy is H, max entropy is H max, and source efficiency is eta, and redundancy is 1 minus eta. First entropy, so K 1 to 3, Pk log to 1 by Pk. So the probability of first is zero point 0.7 log to 1 by zero point 0.7 plus zero point 0.2 log to 1 by zero point 0.2 plus zero point 0.1 log to 1 by zero point 0.1. So if you using your calculator, you calculate the probability of each message and sum them up, then you will find the answer is equals to 1.1568 bit per sample. H max, we already know the formula for H max is equals to log 2 of m. M is the number of samples. You have 3 samples, log 2 of 3, that is equals to 1.585 bit per sample. Third one is the efficiency, which is the ratio of H and H max. So you can use values that you have already calculated. So that is 1.1568 divided by 1.585, and then using the calculator you can say it is 0.73. The redundancy is 1 minus eta, so eta is 0.73, 1 minus 0.73, then you can say the redundancy is 0.27. Let's do one more example. A discrete source emits one of six symbols once every message. The symbol probability is given 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32, and 1 by 32. You need to calculate the source entropy and the information rate. So if you want to calculate the information rate, so the we already know that the information rate is equal to R is equal to R multiplied by H. So for this formula, you need to calculate H first. That is the source entropy. So which is equals to uh, H is equals to summation from K is equals to 1 to 6 pk log to 1 over pk. So then you can use the values. The probability of first message is 1 by 2. So log 2 1 by 2 plus 1 by 4 log 2 1 by 4 plus 1 by 8 log 2 1 by 8 plus 1 by 16 log 2 1 by 16. And we have two messages whose probability is equals to 1 by 32. So that is why we are multiplying this with 2. So 2 multiplied by 1 by 32 log to 1 by 32. So the third denominator in this line, you can see third denominator will go upstairs. 2, 4, 8, 16, 32. So because this is 2 multiplied by 1 by 32, the answer is 1 by 16. Log 2 of 2 is 1, so that is why 1 by 2. Log 2 of 4, so that is 2, so that is 2 by 4. Log 2 of 8, that is 3, so that is by 3 by 8. So log 2 of 16, 4, that is 4 by 16. Log 2 of 32 is 5, so that is by 5 by 16. So if you sum them up together, then the entropy will be equals to 1.9375 bit per second. And we know that the rate that is equals to R multiplied by H. So you can use the values. So R is 10 raised to power 3 multiplied by H is 1.9375. That is why the R will be equals to 1.9375 bit per second rate. That is the information rate. Because that was given, uh, that the value of R. So R is equals to 1 by T, because that was given millisecond. So the T is millisecond, so that is by 1 by 10 raised to power minus 3. So that is by 10 raised to power 3 message per second. So I hope that you understand all the examples, but if you still have any question, you can write the question in the comment box and we will try our best to answer the question. Thank you for watching the video.